Hello, today we are talking about understand the slope-intercept equation for a line. So we've talked about it already, y equals mx plus b. This is slope-intercept form, and that's because it gives you the slope, that's your m, and your y-intercept, that's your b. So if you notice here, I wrote y equals mx plus b, and I drew an arrow to the m, stating that's your slope. It's also, we've talked about, it's your rate of change, and b is your y-intercept, which I also said is your initial value. So those are two things we've talked about, two ways of saying each one. So what we've recently seen is when the y-intercept is 0, the equation simplifies to just y equals mx. You won't have the 0 there. It won't be present because if you add 0 to anything, right, 5 plus 0, it's still 5. So here mx plus b, if b is 0, you would have mx plus 0, that's still mx. Okay, so that's why you're only going to see the first two if your y-intercept, if your initial value is ever 0, which in a lot of cases it is. Let's take a look. We're going to compare slope to similar triangles. So when you have similar triangles, the angles are equivalent, the measurements are equal. So, for example, A is equivalent, the measure of angle A is equivalent to measure of angle D, right? And that's what this is saying here. The measure of angle A equals the measure of angle D. So if A is 90 degrees, so is D. And then, so what we're doing here is we're going to compare the measurements, the same ones to the same ones. So if A is equal to D, then AB over DE should be this equivalent number all around, this ratio. So AB over DE, well, AB is 4 and DE is 8, so 4 over 8 equals 1/2. Similarly, if you look at the green, the measure of angle B equals the measure of angle E. And if we compared the ratios, the similarity there, we've got BC over EF, which is 5 over 10, and that's 1/2. And then lastly, the measure of angle C is equal to the measure of angle D, so then these are proportional, the relationships. So we look at AC over DF, which is 3 over 6, and that also is 1/2. So if you notice, all three side lengths, when you compare them, they give you the same measurement of 1/2. So regardless, no matter where you're looking, that's the relationship from one triangle to the next. This first triangle is half the size of the second one. Or in other words, this triangle, this DEF triangle, is twice as large as this one because this is half as large, right? So the similarity and slope are similar, and here's why. If you pick any points on a line, you should have the same slope. So that's what we're going to talk about here. So if you could quickly pause the video and draw this coordinate plane and draw the points that I'm going to darken right now. I've got the point 0, 0, 1, 2, 2, 4, 3, 6. All in bold. There are more points on that line, that's why it's a line, but those are the 4 points that I wanted to highlight. So if we were going to find our slope of this line, we start at a point, any point, and then we rise from that point, and then we run, right? So from this first point, I'm rising 1, 2, and running 1. So my slope looks like it's 2 over 1. Well, let's say I didn't just start, if I started here, but I didn't finish at that first point. So let's say I rose more. Let's go up 1, 2, 3, 4, and then I go, and then I run 1, 2. So that would be rise over run, which is 4 over 2. How are these equivalent? Are they? 2 over 1, does that equal 4 over 2? Because it's the same line. I didn't change the line. And yeah, if you simplify, 4 over 2 does equal 2 over 1. Well, let's say we went not 4, but 1, 2, 3, 4, 5. Sorry, 6 up. And then we went to the right. Then we went to the right 3. Right? So then 6 over 3, is that equivalent to these other two fractions? Yeah, all of these fractions equal 2. So talking about the proportionality, like with similar triangles, it's the same thing. These are all similar triangles that I just created, all of the same angle measures, right? And that's why they're all going to have those same proportional relationship. So the point here is, the gist of this is that you can pick any 2 points, right? If I started here and I went up 2 and over 1, it's still the same slope. Or if I started here and went up 4 and over 2, it's still the same slope. So you can pick any 2 points on that line and they will give you that slope of 2. And another way to talk about it is, we've talked about a formula. We've got to practice this a bit more. We've got m, that's my slope, equals y2 minus y1 divided by x2 minus x1. So you can pick any 2 points. So let's say, let me use a different color. Let's say I pick 0, 0 and 2, 4, right? 0, 0, and 2, 4, and I'm using it in the formula. Well, I've got an x and a y, and another x and a y. So I need to pick one of them to be the 1s and one of them to be the 2s. I always make the first one the first x and y, and the second one the second x and y. So what I'm doing here is 4 goes in for y2 minus 0, which is my y1. So 4 minus 0. I'm subtracting my y values. Over, then x2 is 2 and x1 is 0. 2 minus 0 is 2. And 4 divided by 2 is, hey, 2. Same slope. It is that line. It should be. And then I just wanted to show you one last time. Maybe I use these 2 points, 3, 6, right here, and 0, 0. I picked 0, 0 just because, you know, it's an easy number to subtract or add with, but I could have used that number. Now again, this is my x, y, and this is my x, y. I'm always going to call these the 1s and these the 2s. So I have 0 minus 6. And in the denominator, I have 0 minus 3. 0 minus 6 is negative 6, and 0 minus 3 is negative 3, and negative 6 divided by negative 3 is positive 2. All right, cool. That's all about slope-intercept form and understanding it.